Welcome to episode number 42 of this series where I'm programming a game live on Twitch Mondays and Thursdays 9 p.m. Eastern. Thanks for joining me here. Last time we spent some time getting the attribute programming working, and then I got then we got the MMC3 tables getting set up properly. So I believe I put a little thing for that here. So we initialize our mirroring and our banks so that we have the right sprites and background data. And then we went through the process of trying to see if we could create an in-memory representation of the entire screen in order to facilitate collision detection. And the reason for that was that, if you'll recall from last time, if you have your screen and you have the blocks that form up the wall, and let's say we have some barriers here. Those are meta tiles, and these are meta tiles. Everything's a meta tile, right? And depending on where the ship is, obviously it may collide with one of these meta tiles, and more importantly, with one of the blocks that makes up the map. And we use an example where we showed that if what we were drawing on the screen was particularly sparse in terms of the amount of space it took up in the meta tile. So if we had some sort of piece that maybe was angled like this and it filled the meta tile, that realistically we would want this area to be non-collidable, and this area would trigger collision. And if we were storing the collisions at a purely tile-based level, we could do that, right? Because we would be storing each of these pieces here as a collision bit, if nothing else. That's too many. It's, maybe a bit that represents the collision for each of the tiles in the meta tile. But the problem ultimately was that if we're not storing the collision at a sub-meta tile level, then with something like this, the ship being over here, if that sprite overlaps, we're going to consider that a collision, and that's no good. We want it to be that it doesn't collide, at least until we get over here, and then we can make sure our art, works accordingly so that you don't get any cheap collisions where your ship explodes for no reason, or seemingly no reason. That always bothered me playing old games where the collision detection was bad and it seemed like you died for no reason. So we'll try not to do that. And the problem was that the map data was constructed by loading an entire screen once, and then this is the map data in terms of the file layout. We have these one row strips of the map. And the reason that I did that was because it made it easy when we started the game. We just immediately load the first screen, and then we, in what appears to be reverse order, but is actually the same. We're just traversing down this file structure to load the rows into the name table, and we get our level. The problem is that then we don't have any good representation of what the map currently, or the screen currently, looks like for when the ship is flying over it. And so the idea was that I wanted to try and in memory construct a representation of what the screen looked like at any given point based on the position of the ship on screen. And what we found was that we were using a lot of cycles. So in addition to some of the weird attribute bugs that had been introduced by this, you can see the flickering that's occurring as we hit boundaries of meta tiles, and that is because the duration of the NMI seems to be too long, and we can sort of visually see that by I'd created this let's see, what did I call it? There was something that I had created so we could turn on the, yeah, there it is, perf debug. So I created something so that we could see the, well, you know what, I think I can do it right here, so that we can see visually what the problem looks like, or what the cycle timing looks like. Assuming I did that right. Yeah, you can sort of see it. Color difference isn't quite as dramatic as I was hoping. Or maybe it's so bad that the well, it seems like it's doing it, but it's not. Again, it's not quite as visible as it was. Not quite as visible as it was when I was using FCEUX. So what is scroll overlay? Show PPU scroll overlay. Show tile grid. Oh, that's cool. So you can see the attribute grid. Highlight tile selected in char viewer. So I guess this is showing where the scroll position is. Oh, at that cycle, really? 190. Okay, I see. So what's kind of cool is you could say, okay, at 0 I want to see what the screen looks like, and you can see it did a jump there. That must be a timing thing for setting the scrolls, the scroll registers, that it's not doing it properly. Or maybe it's not that. Maybe it's related to some sort of buffer overrun, because it's kind of odd that I'm seeing it jump like that so dramatically from one name table to another. I want to try something here. I'm just going to define a few bytes here. And basically what I'm going to do is I'm going to do what's sort of called a sentinel, where you define some bytes in memory at the end of a buffer, and you look to see if it changes. And if it does, then you know it's not supposed to change, but if you see it change, then you know that somebody has, or some bit of code has overwritten your memory. Let's see. So clear memory. We can do it after the clear memory. So let's do this. Let's load A with, and what did I call that? Called it meta tile end. For a meta and x, increment x. Got to increment x again. Metatile ned. Nope. Metatile end. So let's see here. So we've got our 4 bytes that we're storing. Got a 0 out. X here. All right. Let's take a look at the memory. We start the game, and we want to look at our memory here. And you can see it's DEAD BEEF. That's a reference to the old IBM systems I used to work on. In my previous job, the debugger would initialize unused memory to the digits DEAD BEEF, or dead beef. That's how, if you saw a pointer that said dead beef, you knew that you had read something wrong, or you were reading uninitialized memory. So let's see if we're overwriting that sentinel there at all as the game runs. No. So far, it still says dead beef. Alright, so it doesn't look like we're actually overwriting that memory. Let's see here. We have the attribute buffer here. Want to do the same thing, make sure we're not doing the same thing, and but just at the beginning with the metatile, the attribute buffer. So let's copy that. And we should see, so that's at the beginning, and that's at the end. So let's see if either of those change at any point. No, that looks like they're okay. I'm not seeing. So, all right. Well, I thought maybe we were just overwriting the bounds of our memory, but it doesn't appear to be the case. It looks like we're actually just running out of time. Now, I can't remember. This gives you a visualized view of what's happening. I don't know that I care about the register writes and reads, but I do care about the IRQ and the NMI. So you can see the IRQ, I believe. Oh, right. So the IRQ is happening here. And the NMI is happening So what am I, is it, so this is like a steady NMI, or roughly steady NMI, where it's happening. Let's slow this down a little bit so the thing isn't bobbing around quite so much. So that's telling us what? Scan line 241, cycle 27. Okay, so that's telling us that's where our NMI is happening, and the IRQ isn't firing right now. And then when we start the game, there's the IRQ, and I guess it's showing where on the scan line it's occurring. I guess that makes sense. So the NMI is happening when we hit the bottom, and this is happening here where our status bar split occurs. But what's interesting is we still are seeing these jumps, right? Like we're seeing these jumps that are very strange. I don't see anything in this that, well, I guess this is just showing when it occurs. It's not showing whether or not when we're finishing up. So can I, in the assembler, can I, oh no, not that. In the debugger, can I actually, at the end of the NMI code, put another marker? That would be pretty cool. So we put it right at the RTI, the return from interrupt, so we can see where we're hitting. Let's see. I mean, that's going to stop the code. Marked breakpoints. I feel like there's a way you should be able to just say whether you want this to at a breakpoint. Ah, there we go. So now it's going to mark it on here, but it's not going to cause the game to stop executing. So we can see. All right, so yeah, so there's a pretty big jump. And then you can see that when that happens, we get a sort of a corresponding visual glitch. It's usually when, let's see, how far over is it going? Let me restart this. Man, just when I thought it couldn't get any better. So, is that the breakpoint that I'm seeing? Really? Scan line 339, or wait, I misread that. Come here. Breakpoint, cycle 336, scan line 241. 241, 27. It's using that many cycles doing nothing? Or is it just that's when... Interesting. I'm not sure. Oh wow, so it like just totally disappeared off the graph here. Let's see. Yeah, so it's going off the bottom, which I assume means that it's happening outside the time we have allotted for anything in NMI. I think I understand. So this is when NMI triggers. This is when the NMI triggers, and these are scan lines that don't show, but if you read the documentation, I think the scan line counter does actually go technically past the bottom. And so we're getting these visual glitches when we're running out of time because it's basically come back to the top, and now we're modifying it while it's starting to draw. Wow, okay. Hey, Vastrek. Oh, okay, cool. Thanks for letting me know. All right, so, and this is our IRQ that's happening there. So, I mean, the challenge is here that we could change this so that we're not... I'm wondering if it would have been maybe more straightforward to just represent this all as one long buffer now. And the reason being that, you know, you start at the bottom of the buffer and then you have a pointer to the top, and then you scan up the structure. And then when your sprite is moving, it's looking at which metatile it overlaps with, and then you use that to look up your collision data for that metatile. That might also be more than we can handle. I mean, the other thing we would need to do is we would need to stop interspersing the attribute data. So right now, if you recall, we spent quite a while alternating between the map data and then the attribute data. And, well... that would have to change. And at that point, if I'm going to change that, then I would likely want to look up the attribute data based on the metatiles. But I think that that's going to be more complicated than I want to do right now, because otherwise we're going to spend a lot of time doing that. Let's see, but if we switch to directly representing the memory, the attribute information in the file, then we don't need the attribute buffer we were using, because then at that point I feel like the asset tool should just generate the attribute buffer directly. Which is also kind of a pain. All right, so I'm debating what the right approach is here, because as much as I kind of just want it to stay the way it is, we know it's not really performant. And I don't know, given how many cycles are being consumed by the approach we're taking, I'm not sure that even optimizing our lookups will help us when it comes time to handling how we're going to be updating the screen buffer. So what I think I'm going to do for a moment here is I'm going to save off these changes because I'm not crazy about how these ended up working out for the metatile buffer. So let's stash this change, metatile buffer, implementation. So I'm going to save these changes here and then go back to this code, and if we take a look at this, how this performs in the event viewer, I want to look at what that shows us here. Let's get rid of all of these breakpoints here. And then let's set our breakpoint for marking in the event viewer, and let's see what this kind of reveals to us. So here is NMI occurring. The IRQ isn't happening at all, and the mark breakpoint isn't getting hit yet. So did I really? Oh, okay, wrong RTI. I was like, that seems odd that it's happening way up at the top because it shouldn't. All right. My mistake. Yeah, that's better. So you can see that, well, maybe you can see, I don't know how well Twitch is showing you, or the recording is showing. So you can see that this is where our NMI normally ends, and then it's generally coming around here. So we still have some cycles left after we process the metatile load. So it's not great. We can see that visually we can see here that in the event viewer we're getting real close to the bottom here, which explains why when we added some additional work in, we were hitting times where we were going past the bounds of our view blank period and then causing those weird visual glitches that we were seeing. So all right, I think what I want to try to do is change the asset tool to write out data for the map directly. See if is that going to simplify the process of processing. I'm still not 100% convinced that that's going to really save us anything. I think maybe we should focus on how this is all incrementing. So right now we have a couple of things, right? So we have camera Y, which really doesn't actually tell us a camera position. It's just sort of a per pixel counter. So it's telling us, okay, how many pixels have we traversed on the map as we've scrolled. And when we get to 8, then we say we want to go to the next row, right? So if we're looking at the screen, we've got one tile, camera Y counts from 0 to 7. We hit 8 and we say, okay, we're actually on the next row. I wonder if we could load a whole row of meta tiles. I don't think we'd have enough time, because we'd constantly have to be doing the lookups for each individual meta tile. If it were optimized in such a way that the individual tiles were what we were loading, I think we could do it, but because we're doing meta tiles, I don't think that'll work. So yeah, so we're incrementing that, and then we are simultaneously decrementing this mtile y, which is the internal meta tile counter. And what that's doing is that's counting how many of the tiles within the meta tile we've traversed, essentially. And once we hit 4 traversals, then we know we need to load another meta tile. And then we actually increment the what's called the tile Y, which is the lookup into the map. So we have the map over here, and we increment that position by 16. And it's a 16-bit counter, so if the carry is set, then we have to increment tile Y plus 1. And then using the map address, so like this part we could probably optimize. We don't have to keep looking up. We don't have to keep operating on this counter and then recalculating, okay, here's yeah, so like we keep changing row mem and row mem plus 1 based on the value in maps high and maps low. We don't have to do that, because every time we do that, we're essentially just incrementing that value. We're incrementing row mem by 16, and then same thing, if the carry is set, then we can increment row mem plus 1, because we've overflowed and carried, and we need to increment the 16-bit value that represents. And then, yeah, so we should be able to do that instead of doing that lookup for maps high and maps low. I'm not sure why I decided to do that initially. So let's try that. So, well, first of all, not row meme. All right, is that? So that's an interesting thing. So we'll have to initialize row-mem to point to the right location, you know, in terms of where the map is, but we can remove this. Well, let me do this in a just slightly different order. I was going to deal with it in the same order it's here, but it really doesn't make sense to do it that way. So load a row-mem, clear carry, add carry, 16, branch carry clear, done, row-mem, otherwise increment row-mem plus 1, done row-mem, store row-mem. So that moves that to the next row. We don't have to look it up anymore and do this or that or that. So that removed quite a bit of looking up and doing some stuff that we didn't need to do anymore. And then what we just need to make sure we do is when we load the level, we want to make sure that row-mem is initialized properly. And so what we can do is instead of let's see. So this was tile Y. So tile Y is getting set to this. So basically what we want to do is we want to say, we want to change row-mem to be the location from the map plus that 6C. So we can do that here, right? We can say store a row-mem, store a row-mem plus 1. And we're using sprite mem in here, where we're reusing it here, maybe unnecessarily, but that's okay for now. Let's just leave that. So now where is that? The end of that call. Here. So instead of changing tile Y, we can load a, well, we're doing that, right? And then we're going to clear carry and add carry to row-mem, and then branch carry clear to done with row-mem, and then not done with row-mem, done with row-mem, store a row-mem. This will increment row-mem plus 1 because we carried. And there is a scope, so we don't have to worry about that label being the same. And is this at? 1247. So now here we're just incrementing ROMEM and ROMEM plus 1. Let's see if that produces the same result. Hopefully I did that right. Nope. All right, well, we can debug this, so let's take a look. Ah, man, this is so much easier to work with than just the straight up assembly. Except it's not. Come on, scroll to the top. Story. Let's take a look at this here when we restart. I want to make sure this makes sense. So it's going to load the level. So we're storing 4C. Okay. So what? ROMEM plus 1. Loadex param 1. Maps high. Store A. That is not supposed to be empty buffer index. That's supposed to be ROMEM plus 1. And then sprite mem plus 1. Something looks confused. ROMEM, sprite mem. That looks correct. I wonder if the disassembly had a problem. So 64 in hex. I think that's right. Yep, that's right. It's 100. All right, so now ROMEM is pointing to 4C and 7F. So 7F, 4C. Let's take a look at that. Or is it 4C, 7F? No. Sprite mem, 4C, ROMEM. Oh, is it EA4C? Okay. And that's 64. Okay, so that's the right location, so that's good. And then at the end, I want to increment ROMEM. So ROMEM has 4C. So in clear carry, I'm going to add the value of A to that. It's not, didn't carry, so we can store that into ROMEM. So that's now EAB8. And that's, let's see, is that right? Where is the first? So we have, this is the row count. We have 4 palette values, and then we should have 56 right, 56 metatile values, and then 56 attribute values, and that gives us EAC1. Seems like it's a little short. Am I storing 56 or am I storing 64? I might be I'm storing 64 there. Oh, and that's why that buffer needed to be 64 bytes also. Yes. From last time, if you remember, I was confused about it and why it wasn't okay with just the 56 bytes. And that probably is why. All right. Where is it writing out the whole screen? That's the map, 64 bytes. No, these are the attributes, 64 bytes. And then this is map width times 7. So 8 times 56. Yeah. So it's 56, 64. All right, so we have the 1 byte for the size. These are the 4 bytes for the palette. And we have 56 for the first screen, 64 for the attributes, and then that's our first row, which is all zeros. EAC1 is what this should say. It does not. So let's restart here for a second and look at what is this? Find previous. Okay. Let's restart here for a second and load through this again and look at what the initial value is. So EA4C EAC1 minus EA4C 75. So it's 1 plus 4 plus 56 plus 64. Oh, doing this in decimal instead of hex. 1 plus 4 is 5 plus 64 plus 56. So 7D is what it should be adding. And I guess it's not. It's not. So that explains why it's not in the right spot. All right, so EA4C, and then we get down to the end, and row mem is EA4C. Now it's EAC9. That's different than what I thought, but I could have just done the math wrong. That, I mean, that doesn't look unreasonable. Row mem EAC9. 1, 2, 3, 4, 5, 6, 7, 8, and then attribute memory. That seems wrong. Seems wrong. Sorry, this wasn't exactly what I wanted to be. Okay, wait a minute. No, that seems better. Right, we're seeing some of the meta tiles now getting loaded properly. I guess we're just kind of missing some of it. Go back to the map and tiled for a second here. There's this whole green section right at the beginning that appears to have kind of been compressed out from maybe just a bad increment, right? Because it looks like we're just skipping. We've got these meta tiles and then we're skipping. So let's see. Let's see what I'm doing wrong here. So first time through, oh, you know what? It shouldn't be incrementing, or it should be, I'm definitely one row or one set of 8 too high in the beginning, because it's going to initially increment. So this is an initialization problem here. So this value that it's going to be loading, the 7D, is technically not right, because we need to, okay, so maybe that's why. So 6D, So that makes sense that that's now there, because the first time through we're automatically incrementing row mem to what would be the next row. So we need to be kind of one behind, if I'm remembering our file format properly. We've got our row count, 4 bytes, 56 bytes, 64 bytes, and then after that we've got our interleaved, what we're calling our interleaved map format, which is alternating meta tiles and attribute values. So 16. So this should be okay. Are we doing anything else with row mem? So at this point we're adding the 16 to it. And then are we adding 16 too often? Yeah, so we shouldn't be, okay. So we shouldn't be doing this increment here. Should be doing it here now. Because now, before, with it where it was doing the increment every sub row, which meant we were skipping too many. We were skipping tiles, which is what we saw. There we go. Nice. So that's working now. So now the question is, do we need to be doing this math with tile Y? what are we even using it for? We have mtile_y that we're using. We're adding, we're doing that. That's mtile_y. So maybe we don't need it. We may not need this. Oh wait, we need that for this, for loading the level. Whole word. But now we don't need this here, so this can go away. So that took some code out of it. So if we look at source tree, we can see we added a little bit of code, but we took a chunk out, and the stuff that we took out involved looking up in these maps locations versus just doing some simple increments. So I think if we look at the event viewer now, we should see better performance, I think. Let's take a look. Yeah, so you can see that it was before, it was over here and kind of down here, and this is a little bit higher and closer to the top. So that means we're using less cycles overall. We can, now the cool thing is we can even see if we can get some empirical numbers here on this. It'd be cool if this showed an average of values, but let's do this. Optimized tile loading. So we're back to the code without those changes, and let's take a look at what this looks like here. So if we run this, and we'll run it at a slower speed so we can get some actual values. And just jot these down. So what we're seeing, make sure I rebuilt that. Go to that, go to location. Beautiful. All right. So what we're seeing here is $247.91. And what was that? Gotta wait for it to hit the boundary of a meta tile. Oh. It's a little too fast for me there. Damn it. that's actually, that was off the, that was over here. That was pretty bad. That had gone up to the top of the screen. That was 253, 206. 253, 206. Let's see. So and that was just a regular tile update. Let's see what happens with the meta tile update. Yeah, so see, it was up there. It had already wrapped around, so that was pretty bad. We're getting pretty inconsistent and also wrapping around on the V blank. So we're exceeding the V blank sometimes. So now let's go back and let's apply the stash. This one. So I'm just reapplying those changes we just made. And we'll see if we see anything better here. We just got to change the debugger to have the right breakpoint now. So done, mark it. There we go. I love using this debugger, if I haven't said it enough. It's just so much better. All right, so now let's see where we're at here. Okay, so we're loading the game, loading the map. Okay, so now we're at 247.95, 247, okay, 247.91. That's basically what we were seeing before. $253.110. So it's still at scanline 253. It's a little bit more efficient. The question is, are we going to see any times where that event shows up on the top of the screen? 253. I think it was up here. It wasn't quite as far down as it was, but it was still it was still on the top. Damn it. So we could still do better because we're still in some cases we're still running past our allotted time here. There it is. I mean, it's close. I feel like it was further down a little bit when we were looking at it before, but it's still wrapping around. Wonder if that's what's causing the sprite flicker. Or if that's just an artifact of Mesen expanded so large or something. No, I'm still seeing it there. Maybe it's something silly, like I have my sprites placed there or something. I don't know. So that's interesting. Why is it saying there are reads and writes to the mapper registers? Because don't recall that I'm changing those except in the beginning, but maybe there's something messed up. Let's take a look here. Oops, it's a script window. No, not that. Add to watch. No, it didn't like that. Let's close this down and open it up again. I've seen it do this before, rarely, but still, I think it happened on the first time we were using this, when I tried to set a breakpoint. No. Debugger. I'm not sure what the syntax is here. It doesn't like that. Okay. I don't know why it doesn't like that, but okay. Is it only for variables? That. How did I thought there was a way to access counters. Oh, really? Huh. Oh. Wow, okay. Exclusive time. Count call. Is there a way to... Is there a way to... No? That's cool. So you can actually see which addresses you're writing to most, or reading from most. Be cool to see the average cycle count. But so this is telling me where the percentage, what percentage of my code comes from what calls. I mean, and it's obvious that it would be vblank and reset because all of these other ones are pretty much just done once, I think. What I'm kind of curious about is why. So I still have these. Let's see, 7. Oops. I guess I don't need these anymore. FD. Where is it doing that? 7FD. E. Oh, is it still looking for whole word only? Yeah. Oops. So these were places where I was writing to memory as parts of the Lewis script that I was using. I guess I don't need that anymore. Not that that's gonna make or break our game here, but might as well take them out of the picture. FE, why is that still being... Sort by read count. I'm reading that a lot. 81. Right count. All right. So, sorry, this is kind of took a sidetrack here. I guess the question now becomes, what can we do to make this work better? Come on, restart. I still don't understand why it's showing these as mapper. Oh, yeah, okay, no, never mind. I do know why that's showing up, because that's the counter configuration. I forgot about that. All right. And that's where we're accessing the PPU. That makes sense because we're constantly doing stuff, but you know, so you can see, or maybe you can't again because of the draw rates here. You can see that we're getting overrun. Oh, damn it. Overruns in our NMI. It's not terrible, but I'd like to make this run. I mean, we're really not doing much of anything, so we shouldn't be doing PPU updates that are overlapping into the actual draw time of the screen refresh. So, all right, so how do we make this more efficient? Well, we eliminated some code here with ROMEM to make that work better, so we didn't have to use tile Y anymore. We were just directly updating ROMEM based on if we were based on the fact that ROMEM could effectively do the lookup into the map and keep track of where we were in the map all in one one counter. So that saved us from having to use that. So the next question becomes, what else can we do like that where it's gonna save us time because we don't have to do extra work? Now I'm doing load, set and subtract. And I think that's because, I want to double check, I'm pretty sure that's because the decrement instruction does not update the carry flag. Where is it? Yeah, so that doesn't decrement carry. Although I'm not even looking at that, am I? I'm just comparing it to see if it rolled over. So this is dumb. And here we're incrementing, loading and comparing, and then we're branching. What is the value of EF here? Okay. Increment camera Y, load it, compare it to 8. Branch if it's equal to increment meta tile sub row, otherwise skip row load. We're then zeroing out camera Y, decrementing M tile Y, loading it, checking to see if it's FF. Same thing, we're doing a branch if equal, otherwise jumping to load new row. Load 3, store that in M tile Y. Load A1, store it in meta tile flag. Well, you know what? We can actually, I think we zero that out, so we just need to increment that. I mean, these are not going to be earth-shattering things that save us tremendous cycles, but as I see them, I want to change them. Load a row mem, clear, add, blah, blah. I wonder if there's a faster way to do that. I'll have to look and see if there's a better way to do these 16-bit additions. I feel like there probably is some clever way that somebody figured out. And then we're at the loading of the new row. So we take M tile Y and we shift it, and then we put it into temp, and then we, let's see, and then we take screen memory position and write it into 2006, which is where we want to write our new row of data. So Y, let's see, so we're taking M tile Y and shifting it and then adding it to the meta tile value for the map data. So why do we have to do this every time? Tile Y. It's the row. Load. Oh, I see. I guess we don't. I mean, if we know. Until mtile Y gets reset. Yeah, this is kind of dumb because mtile Y is only going to ever be one of 4 values. It's going to be 3, 2, 1, 0, and then when we get to FF, it will decrement to, or when we get to 0, it'll decrement to FF, which means we reset it to this. Why not just pre-do the math, right? We say the initial value is 12, not that 12, this 12, this 12, because A is 10, right? So that 12, and then we don't have to do this multiplication anymore because mtile Y will already be the right value. And then instead of just decrementing mtile Y, we have to do a little bit more work. We can do repeat 4 and rep. So we have to decrement it. Well, that's probably worse than what I was. Yeah. So load A mtile Y, set clear, subtract carry 4, stored mtile Y, and then compare it to not FF anymore, but if we take 0 and minus 4, we get FC. Let me load that back. So it would be C minus 4, 8, 4, 0, FC. Okay. So that then means that mtile Y has to be initialized differently. Load A mtile Y. Basically, I'm pre-computing the multiplication so that we don't have to do that anymore, right? If mtile Y is only being used for this purpose, then always have it represent a value that corresponds to what it would get turned into before we do this load and add, and then we can just use the value directly. We don't have to use that temp value anymore, and we don't have to do the shifts anymore, so that saves us some cycles there too. So let's see what we got now, assuming that I didn't break it. Okay, it looks like it's still working. It's good. We're still seeing a little bit of the overlap here, but it, to my eye, looks like it's less. I mean, I don't know that we're going to see a huge gain because this is only being computed, or it's only being used every time a tile is loaded. It looks like the big computational expense is happening when we go to the next meta tile. Or potentially the next attribute row. That might be, it might be that it's when we hit the next row of attributes that we're seeing that. I mean, it definitely, you know, doesn't hurt to do these kinds of optimizations, but I want them to be worth it. So let's see. You know what we can do? We can set another marker. Oh, this is actually in the wrong spot now. Remove this. Let me just turn off the breakpoint, and we add the marker back and see it. We don't need the register rights. Oh, we do. Well, I do want the register rights, but they're getting in the way of. Yeah, you know what? That would make sense because we're also seeing them clustered in a little bit of a different way. So what we're seeing is these attribute rights, but then we're also seeing attribute rights at the top. I thought I saw that they were split into two sets of attribute rights. It's kind of hard to watch two parts of the screen at the same time. But what I think it is it's updating the rows, and then we're getting the attribute updates at the bottom that's overlapping. Well, instead of guessing at that, hold on a second. Let's pause this here. 23C0, and then we have this long set of repeated writes where we're updating the PPU. We're in this case and I knew that this wasn't a great approach, but the idea was that essentially it seemed like it was faster to update the entire attribute table than try to selectively update it at the time. So let's see. Yeah, so let's look at that one. I can turn them both on now. Of course, that one only happens sometimes. Is there a way to change the colors of them? Yeah, so what it's looking, yeah, okay, and that makes sense. So realistically, what it's looking like is the issue is that we're actually okay in the NMI mostly now. We've cut out some good cruft, but the problem is that when we have to do the attribute update, this approach, even though it's easy, is obviously causing some issues. And it seemed strange to me at the time that this would be better, and we'll have to figure out a way to make that work more reliably with selective updates. But let's see here if we see a different story now. So we should only see these. Okay, so we're seeing them pretty late down in the updates, but we're not I don't think we wrapped around there. Let's see if we see any yellow at the top. Yeah, it's not too bad. I'm not seeing anything up here though that is indicating that we're updating the PPU registers after we've already started drawing, which is what we want to avoid. So at full speed, you know, it's working pretty well. Obviously, we're not updating the attributes right now. So what we need to figure out is, and I know this wasn't what I was planning on doing today, but after we started digging into this, I felt like it was worth exploring some more, because it's still not clear in my mind that we want to change the way we were planning on dealing with the collision. Only because it's a lot of work to rewrite the code to handle loading the tiles differently, as well as storing them differently. And I don't want to do that in a situation where we're not feeling solid about the way that this functionality here is handling the current workload. So now we're seeing that this is working consistently. The sprite isn't flickering. Obviously the attributes are wrong, but we can see that we're basically working within this kind of range of time, which is what we need to be doing. I think we can still trim some cycles here from our NMI, and then see if we can get the selective attribute updates working. So, let's see. What else are we doing in here that... I mean, realistically, what we're seeing is that the additional load of these attributes is what's taking up a lot of time, and the code is streamlined compared to where it was, but it could obviously be potentially made better. Just wondering if it... I'm wondering a lot of things. I'm wondering if it makes sense to be doing this attribute buffer where we're storing the attribute information in memory. I'm wondering if it makes sense to continue to do that. I'm wondering if it makes sense... I don't know. Sorry, I'm still just kind of trying to think this all through here. We're still updating our scroll. We're doing our sprite copy. Okay, so that makes sense. That would explain why the sprite was flickering. It was flickering because we hadn't set up the PPU to do the copy of the DMA. Or the DMA copy, rather, of the sprite information. And so if we ran over the allotted time for NMI, then the copy wouldn't happen until we had already started drawing the screen. So I'm wondering if we want to move that. that up. Just get that process going. So the sprites are set up while we're at the beginning here. Except I copied a load A with 1. Why did I do? Why is that? Oh, you know, that might have been a leftover thing from when I was writing those memories for the breakpoints. All right, so I don't need to do that. Let's do this here. Not that we should see any difference with this, but I just want to make sure that nothing broke as a result of that change. Okay, so the sprites are still showing up. Okay. All right, so nothing out of the ordinary here so far. Although, it's interesting. Why do I feel like this yellow section isn't going as far down anymore? Oh, is that the DMA copy? Interesting. So that might be the DMA copy. Scan line. Register 2004. Store in 4014. I don't know what that would be otherwise. Like if I get rid of, if I comment this out, obviously we're not going to see sprites anymore, but would we see that section go away in the event viewer? Okay, so that's what that yellow, those yellow dots are. Those yellow dots are the DMA copy of the sprites. All right, so that's interesting. So that explains, like I said before, that explains why we were seeing the flickering of the player sprite. It had nothing to do with the way that was being rendered in Mesen. That was Mesen actually rendering properly because the DMA copy was happening by the time we started to draw. So the sprite was already, the sprite was being updated too late, and so we were missing some of the sprites some of the time. Interesting. So then that raises the question. If I bring this back, what do we see that as? Since that's what I thought that was. Okay, so now we're seeing glitching because now we're seeing glitching because it is updating the attribute buffer and running over the NMI because we moved. So before we were updating the attribute buffer and taking up all the time doing that, but then that was problematic for the sprites because the DMA was happening at the end. Now, when we update the attribute buffer, this is happening at the end, and that's causing problems and causing those glitches we're seeing. So if we did, let's just change this to a shorter, to a smaller number of iterations. operations just to get some of the attribute updates happening. So we don't get the glitching anymore. And obviously we're not going to see all of the meta tiles correctly, but it is still pretty expensive. We're seeing operations down to the end of the NMI. So really what that tells me is that our attribute buffer process is still shit. There's no real other word for it. It's still not working well because we're still kind of consuming. I mean, it's okay if we're, you know, partly toward. It's okay if we can feel like we're, you know, using the NMI in a situation where we're, you know, we're doing all this stuff, and you know, occasionally we overrun, and so it kind of creates a weird glitch. We're not really doing anything. Now, the game loop wouldn't affect this, right? Because it's happening outside of the PPU. Those have to go away earlier. But sorry, I'm kind of trying to think of how to explain this. So the game loop wouldn't necessarily affect this update because we're updating the memory for the entities, the sprites, separately from the actual DMA update process. So what we might see is a, you know, occasional glitch on the sprite. All right, so maybe that's not so bad. The only other issue is we're not doing any sound right now, any sound processing, and we're running out of time. And I believe that's normally clocked in on the NMI to keep it consistent at a locked rate of playback. So we got to figure out what we can do here again with the attributes to make that work better. And then so that's the other thing, is we're not doing any collision detection right now, which would happen in the game loop. But if the game loop is using a memory buffer that we're setting up in the NMI, then we need to rely on the NMI to be locked in at least the same rate as the game loop in order to ensure that we're not getting glitchy collision where, you know, you might actually go into a row that just got loaded and where you're supposed to collide, but you don't because the buffer hadn't gotten updated, so you get some weird artifacting there. If we're just looking up into a location in memory for that collision, then we don't have to do the processing of the buffer in the NMI to maintain the meta tile, the current loaded meta tiles in the name table, and then we only have to look up the position in the game loop, which is a little bit more forgiving because we can handle the game loop while the screen is being redrawn, which gives us more time. And let's see what else. And then it's going to be less glitchy. So maybe that's our argument for refactoring the way that we do the storage of the level to be linear instead of this weird sort of broken out format that we're using right now. And then that would get us gains there. And then the only other question is, what impact, if any, is that going to have on the attributes? Because we're not going to, I don't think I'm going to keep a separate table of attributes although we're technically currently doing that. But if we're going to do that in a linear fashion like we're doing for the map, so we're going to change our map around to what we probably should have done in the first place, where we just have, you know, boom, map, right? These are all meta tiles. We would need to have a similar one of attributes, because we have that corresponding, unless we want to do a lookup. I also need to sorry, I'm just thinking this through. Do we need... We may not need a buffer that holds... every single attribute value. We probably only need a table that can, an array that can hold 2 rows of attribute values, because if the attributes are rows of 8, in one mode we're alternating between updating an entire row and being done with it, and updating half a row at a time, because of the way that the attribute gets split because of the number of rows in the screen. So we technically only need up to 2 rows at a time, and then we could just store where we are in the attribute memory and update just those 2 rows. That would work. That'll save us memory. That's not going to save us cycles, because we still have to do the same messing around with bits that we're doing today. Except, let me think. Well, maybe not. That might not work. That might not work, because then we're... Yeah, that doesn't work, because then we don't have the current values to update for... Yeah, it sort of... So the idea makes sense, sort of, but it's not going to work. That's... We need to know what it was previously before we can update it, and then once we're done with that row, we don't come back to it until later. The prior values of another row aren't anywhere to be found. We can't get them out of the attribute table, so that wasn't going to work. I mean, and then realistically, the other thing that we've talked about a little bit is, you know, if we're talking about 100 rows, that's 800 bytes for the map, and then that's 800 additional bytes of attribute memory that we're storing in the map. We really should be able to look that up, and that'll save us space in the ROM. And if we can structure the lookup such that it's very simple to calculate, then we should be okay. Right now, the meta tiles are in an absolute position in the ROM, so there's the we look up the offset of where the meta tiles live, and then or we have the offset of where the meta tiles live in the ROM, and then we use an offset based on the current meta tile value that we've loaded from here. No, sorry. from here, we can look into the meta tiles and actually take out the sub tiles from that. So that makes it more efficient because we're only storing the meta tile values. We just need to be able to do essentially the same thing where we say we've got memory that has, okay, for this meta tile, this is the attribute value, or sorry, this is the palette value, which would then map to the attribute value that we have to update it to. Right now the palettes are fixed, which is why we're pre-calculating the attribute value. I think we'll have to fix that. We'll have to change. Maybe what we need to do is have so what we could do we could have a mapping of the meta tile in the context of the map versus the meta tile in the context of all the meta tiles. So meta tile 0 might be meta tile 0 for that particular map, but then it's meta tile 5 in the context of every meta tile we use in the entire game. But the benefit of doing that is then the palette, because we're only using up to the 4 palettes for the name table right now, we're not doing dynamic palette loads, then the palette we need is just the meta tile value. So the attribute update is whatever the meta tile value is, just make sure that's in the appropriate position in the byte. So it's either the high 4 bits or the low 4 bits. That might work. It means in the asset tool we have to do a recalculation, or we have to reshuffle the meta tile values, but that's not that big a deal to do. So I think that's what we'll do in the next stream, is we will modify the asset tool to change around the meta tiles, one to load kind of more traditionally. All of the data will be stored linearly in the map format, and the palette will stay the same, but the meta tile indexes or indices will get rebased to be 0 through 3 for the map that we're looking at. We can't do it exactly like that because you might have more than 4 meta tiles. So, well, they'll still get rebased. We'll need to have a lookup for which palette the meta tiles use. So we'll need to know how many meta tiles are utilized in the map. That's not a big deal. That's an extra byte that we have to add, but we get rid of every single byte that mirrored the meta tile. So we've effectively halved what we have to store in the map, but have to add a couple of additional metadata type things into the file format so that we can do these lookups, and that should help for the collision. And then once we have that, we can see how that works in terms of this work here, because we no longer have to look it up in the ROMEM. We just go based on a lookup into a table that says, okay, for whatever meta tile you have, it uses palette 0 through 3, and then from that we get our value that we use for this process of masking and re-altering the attributes. And then I will talk to the fine folks at Nintendo Age and get some advice on how they're updating their attributes. I'll do some research on that, because obviously it's not really super efficient to be updating the entire attribute table every time we change one row of attributes. But I don't know that I need to necessarily even talk to anybody about it. I just have to figure out a smarter way to not do all 64 updates and instead do, at most 16. Because it's a little crazy to do 64. And that's where we were seeing the flickering issue here because of updating updating the attributes with the NMI already complete or past the point of being able to actually do that. Sorry, that was a little rambly. Yeah, so the flickering is because we're at a point where... Oh, I was wondering why it seemed like it was so fast. Apparently the trigger on the... Oh, you can rewind. The trigger on the controller fast forwards. So that's what that glitchiness is, because we're updating the attributes after the PPU has already started drawing the screen. Anyway, I think I'm done for tonight. Sorry I didn't get to the collision like we wanted to, but if you've been following this, or if you do any sort of software development, you know that sometimes you go down one path that leads you into something that you weren't expecting to explore, and turns out that it's sort of fruitful exploration and worth taking the time to do for what you were actually looking at doing. We talk about this a lot at work. Sometimes you start doing something and realize that, yeah, you could just kind of write some code that does what you were looking for, but when you're done, you don't know, you don't have a good sense of whether or not what you did makes any sense, or is correct, or is testable, or all of the things that you need to be able to do to actually put out a product. And so in this case, yeah, I could have just written some collision code that kind of worked with our current scheme, but I wouldn't have felt comfortable with it based on the behavior I was seeing in the way that the game was running. And the tools with the emulator definitely helped kind of put all of that into perspective. So feel better about that. And we'll get back to this. I'm not sure if I'm going to be doing a stream on Thursday of this week. I've got some family things going on, so I don't think I'm going to be around Thursday night. I might do this on Wednesday, just because it will be it'll be easier to ensure that I definitely stream. I'll keep you guys posted on Twitter, and I'll let you know what's going on. So as always, thank you for tuning in. I appreciate those of you who came in and watched it live, and thanks for everybody who watches the recordings. I appreciate that too. I appreciate all the comments and questions that have come in, and I'm working on content for the Zero Page series, so I'll have hopefully something up on YouTube for episode 2 in the next couple of weeks. And keep the questions coming, and any suggestions you have for Zero Pages, let me know. But as always, if you have any questions or want to reach out to me, I'm on Twitter at Clairvis, and I'm on Nintendo Age and on the Nintendo Age Discord. A couple people have already said hi to me on there from watching the series. That's pretty cool. It's neat to see people watching. And yeah, so thanks for watching. See you next time. I'll keep you posted on if that's Wednesday or Thursday. Have a good night and have a good week.